On this 2015 to 2025 F150 with the 2.7 EcoBoost, P0014 is a VCT functional fault. In plain language, the PCM is seeing the exhaust cam timing on bank 1 act over-advanced or stay advanced when it should not. The truck may idle rough or feel off when the cam timing is being moved. The broad fault areas can include oil flow or oil pressure, cam timing and VCT alignment, the phaser, the VCT solenoid, or interference issues. Start this one as a command versus response diagnosis, not as a parts call. With the ignition on, check for VCT-related codes and pay attention to any cam position sensor codes first. If CMP sensor codes are present, handle those before continuing this path. For P0014 without CMP sensor codes, move into the VCT operation check. 4. The first functional check. Make sure all disconnected VCT solenoid connectors are connected. Turn the ignition on, start the engine, and monitor the PCM PIDs. VCT XH ACT 1 degrees and VCT XH diff 1 degrees. Drive the vehicle and work the throttle enough to create VCT movement. What you want to see is actual cam movement, while the difference PID stays close to 0. Some trucks need more RPM and load before the VCT system moves, and during quick cam movement, the difference PID may briefly move away from 0. If the system moves correctly and the difference stays under control, the concern cannot be duplicated at that time. It may have been from an oil flow restriction that cleared while operating the VCT system. Clear the PCM DTCs and repeat the self-test. If it does not pass this check, and the engine is rough at idle with running or continuous memory codes present, go straight to the debris clearing step. Otherwise, continue with the solenoid functionality check. Next, check whether the suspect VCT solenoid can move the cam. Do not install a new component unless the test points you there. For P0014, monitor VCT EXH Act 1 in degrees. Turn the ignition off, disconnect the VCT solenoid for the current code, start the engine, and record the PID value at idle. Use a 5-amp fused jumper wire at the component side connector pair for the suspect solenoid. The connector pair options for this engine are C1542 pin 1, C1542 pin 2, C1369 pin 1, C1369 pin 2, C1370 pin 1, C1370 pin 2, and C1625 pin 1, C1625 pin 2. Use the pair that belongs to the solenoid being diagnosed. If that cannot be confirmed, pause, recheck the earlier diagnostic path, and avoid guessing. After the jumper setup, record the PID value at idle again. The decision here is whether the VCT actual PID shows movement of 20 degrees or more. If it does, the concern is not present at that time and may have been cleared by operating the VCT system, so clear the PCM DTCs and repeat the self-test. If it does not move 20 degrees or more, go to the debris clearing step. Now, try to clear possible debris from the suspect VCT solenoid. Keep monitoring VCT EXH ACT1 DEG. Start the engine and record the PID value at idle. Again, use the 5-amp fused jumper wire setup for the correct component side connector pair. Quickly connect and disconnect the jumper wire to the negative battery terminal at least 20 times within 20 seconds. Then connect the jumper wire to the negative battery terminal and leave it connected. Record the PID value at idle. If the VCT actual PID now shows movement of 20 degrees or more, the concern is not present at that time and may have been caused by an oil flow restriction that cleared while operating the VCT system. Clear the PCM DTCs and repeat the self-test. If it still does not move 20 degrees or more, move on to base engine oil pressure. Before condemning the VCT hardware, check the base engine oil pressure. Turn the ignition off, reconnect the VCT solenoid for the current code, and perform the base engine oil pressure check. If there is an oil pressure concern, repair it as necessary. Clear the PCM DTCs and repeat the self-test. If there is no base oil pressure concern, continue to the solenoid activation check off the engine. For the direct solenoid check, turn the ignition off, disconnect the VCT solenoid for the current code, and remove that solenoid. Use the 5-amp fused jumper wire setup at the correct component side connector pair. While holding the solenoid, quickly connect and disconnect the jumper wire to the negative battery terminal. A working solenoid should give a plunger vibration that you can feel by hand when the jumper wires are connected. Repeat as needed to verify operation. If the plunger activates, install a new VCT phaser as necessary, then clear the PCM DTCs and repeat the self-test. If the plunger does not activate, install a new variable camshaft timing solenoid, then clear the PCM DTCs and repeat the self-test. Keep verifications separate from the testing path. Anytime the branch tells you the concern is no longer present, or after a repair is made, clear the PCM DTCs and repeat the self-test. The takeaway on P0014 is simple. Prove whether the exhaust cam responds correctly, confirm oil pressure is not the reason, and only then make the call between the phaser and the solenoid. For more diagnostic training, visit stepdiagnostics.com.